Hello, I'm Mike Dowd, and welcome to my house. My wife and I built this structure about 3 years ago, and it took us a couple of years to build it. Actually, it was great fun. But we had a plan when we put it together. We both have built houses before, and we wanted a place that was quiet, a place that was that felt good, a place that was easy to heat, easy to cool. Here in New Mexico, we get some pretty hot summers, and we get some pretty cold winters, oddly enough. So we spent some time researching building materials and building methods to come up with this. My wife and I built our last one together, actually, and hired a minimum of people. This one was a little bit more ambitious, and we got into a few situations where we actually had to hire some folks to help. We tried to keep that to a minimum. With the type of construction we have here, we needed a crane maybe 2 or 3 times to lift heavy panels up on the roof. I hired several people to help me with concrete work, but we tried to choose something that was as un-labor intensive as possible. This wall behind me is made from insulating concrete forms. These are from Polysteel, marketed locally by Blackhawk Construction Company. They are 16 inches across here and about 4 feet long. And they come in various sizes and shapes for making corners and whatnot. Rebar goes inside, you stack these up like Legos and then fill them with concrete. The least thick portion is a couple of inches thick, which oddly enough makes them bulletproof. A lot of farmers are using them out here for outer buildings that they would have water tanks in, because some hunters, non-thinking hunters, take target practice on some of the outbuildings every now and then. Oddly enough, these are bulletproof. I used almost all the exterior walls are this, and I have a couple of interior walls because they do add significant thermal mass. The concrete inside here, great thermal mass. But as you can see, there's a lot of styrofoam insulation on the outside of it. Very good. The stucco goes right over the outside of that. A special stucco product bonds itself very well to the styrofoam, and then use a fiberglass mesh on top of that, and then the finish coats. Drywall goes on the inside. There is a furring strip that you can screw into, located every 12 inches on these. Very nice product. I really like it. They're lots of fun. And they build a house. When you walk inside the house, it feels like an adobe house. It has a feel to it that you have massive walls on the outside. All the roofs on both the studio and the house are these thicker SIPs, structural insulating panels. Outside of these is OSB, and inside is, on the thicker panel here, is 5.5 inches of polyurethane with a very good R value. R value of the polyurethane is actually far better than of the styrofoam. A few companies use this, but KC Panels in Animas, New Mexico, uses this one exclusively. And they set up their machine so the OSB panels are on the outside, and then they foam this in place, and so it's glued permanently to the OSB. There's no problem with this coming on. But the insulating value of this is an R41 panel. The walls of our guest room down here and all the ceilings are made out of this. I have one interior wall. I was trying to learn how to use this stuff when we were doing it, so I built a house that is mostly ICFs, but some SIPs. I thought, hey, which is better, SIPs or ICFs? So I thought, I'll just use both of them. What the heck? This is the thicker one. OSB is oriented strand board, I believe it is. They take boards, let's see, the plates are made from wood that is farm grown. So we're not using old hardwood growth or anything like that. They farm this stuff, they chip it up, and they bond it together. The strands are oriented in the same direction to produce something like plywood, but it's engineered to give you a very strong, very inexpensive product. It resists termites, but obviously you want to protect it from the elements. This particular company built a thick one and a thin one. I used some of this on an interior wall. The sound deadening qualities of both of these, very good, and of ICFs too. And that was one of our goals in the house, was to make a very quiet house. So I used this as an interior wall down the length of the hallway down there to see, well, how quiet is it when I have the TV set blaring in this room, the door closed, and I'm playing piano in the living room. They're very quiet, and they're easy to work with. Now notice these two pieces that I have here for samples are round. That's because the panels from which I cut them, I needed a hole. I need a hole for a skylight, for instance, so you just cut it out. The panels themselves come in 4 foot wide by anything up to 34 foot length. And when you give your plans to the company, they build your house for you on the computer and then cut everything out at the factory and send it to you. So all the wall cutouts where I use this were already cut out. The door openings were already cut out. And you essentially just take panel 1, put it next to panel 2, put it next to panel 3. They go up, they've either got a plumb cut if it's a roof panel or a square cut, depending on what you order. But they come in 4 foot wide by whatever is required for the project. The outgassing situation for polyisocyanurate and styrofoam seems to be a non-issue in this. If you look at material safety data sheets for these products, it's not a big deal. And the inside of your house, of course, is covered with drywall. It just goes right on here, gets screwed in place, and then that's mudded in. Likewise, these panels either covered with drywall if they're used on the inside, or stucco if it's used on the outside. So it's really a non-issue. I think any outgassing. Some people are concerned about just OSB in general. It's used all over the world in construction today, and is not considered to be a problem with outgassing. I ordered these panels from KC Panels down in Animas, and they delivered to me a product that was used 100%. The waste for building this house, I have right here. I have another one of these somewhere. But that's the total waste on putting together this entire house. You watch a stick house being built, and you can go around it afterwards and gather up the sticks and use them in your fireplace for about a 2-year period afterwards, burning that stuff. With this, there was zero waste. At the factory, you'd say, well, there is some waste. They would trim some things and wind up with lots of foam. But what they would do is gather the foam up, put it in bags, and give it to people who wanted to insulate their attics. This polyisocyanurate makes a wonderful insulation, like poured-in fiberglass. And they were recycling everything that they could possibly do down there. Very little waste at that particular facility, and certainly virtually zero waste on building site. The cost of construction for these products brings the overall cost of a house to about 5% more. 5%, maybe a little bit more than that. However, the ease of heating and cooling, and in New Mexico, you're going to heat your house, you're going to cool your house, one way or the other. The ease with which you can do that greatly offsets the cost. Any cost of your mortgage that you would pay for having an extra value in your home is offset the first year or two by heating and cooling costs. I mean, this house is 3,400 square feet. I am heating it and cooling it with a 3-ton high-efficiency York air conditioning heat pump right now. And it's incredible to me. With the PV system, I'm actually making money on the deal. I'm so thrilled about that. The house itself is 3,400 square feet of heated area with a large 2-car garage. The workshop suits my needs. My wife is an artist, and we built a studio of about 700 square feet for her of similar materials. It also had to be easy to heat and cool, had to be comfortable for her, it had to have north light. Her requirements are slightly different than mine. But we essentially wanted something that we could put together ourselves with a minimum of requirement to hire somebody from the outside. This is the first thing we put up, actually. Insulating concrete form walls, concrete slab floor, frame construction but insulated ceiling. This is the water tank house. The well is 450 feet down that way, but the pressure tank is located inside here. We put this up to get an idea of how to work with insulating concrete forms, and we learned the learning curve with insulating concrete forms is very steep, actually. 15-20 minutes you learn a lot about how to work with them. So we put this together and gained a lot of overconfidence, actually allowed us to move on to the bigger projects. These are 2 SMA inverters for our 10 kW photovoltaic system. I selected an active solar system for the house. I did not want to have to open windows, close windows, shade different walls, do all. I said, hey, when it gets cold, I want to turn the thermostat, say, I want it to be warmer. When it's warm, I want to turn the thermostat and say, okay, I want to be cooler. So I have total control from a photovoltaic standpoint, from a solar standpoint. I can control it. But my PV system on the roof here is always pointed where it's supposed to be, and I'm generating power. The house is well insulated, so I don't lose a lot of heat, I don't gain a lot of heat, so my needs are limited. But I love photovoltaic. It actually pays for itself right now. We have certain tax breaks which made it favorable to install this and brought the price way down. Plus, in New Mexico, the power company gives us 4 cents a kilowatt hour. Not much, but 4 cents a kilowatt hour, in addition to letting us run the main meter backwards. So since March, we have been getting a check every month from the power company. Our photovoltaic system had a big upfront cost. You have to bear that in mind when you're doing this. However, in the state of New Mexico, we get something like 10% of the value off of our income tax, and it's a 30%, I believe, tax credit from the feds. So the actual cost is brought down immediately. Over the years, the payoff on this will be 7 or 8 years, and then it's paid off. The life is expected to be far more than 25 years, so it's not something that's going to wear out very quickly. The inverters have a 10-year warranty. The photovoltaic panels themselves have a 25-year warranty. So you're pretty well covered there, and the life will actually be much longer than that. We get pretty good winds here, and it is not unlikely to see a standard wind in the springtime of 60 plus miles an hour. The requirement, I believe, is to have a house that resists a 90 mile an hour wind. This house is built on paper to resist a 120 mile an hour wind, and I believe will easily do 150, possibly even more than that. The structure itself is several inches of concrete with rebar in it, and it's rebarred quite a ways down, and there's a massive footing. The roof structure is bolted securely at 12-inch increments into the header plates up there, and they're tied in through J-bolts into the concrete itself. So we've built something here that is very wind resistant. I know specifically the company that makes the SIP panels has marketed them to some Japanese home builders that have used them in areas in Japan that have gone through some significant earthquakes. These have in fact, these structures have been the only ones that actually survived the earthquakes adequately. The Department of Defense has been using insulating concrete forms in some of their structures in the Middle East lately because they are highly resistant to bomb blasts, oddly enough. You can blow stucco off of it, but it's hard to get through the structure. Fire resistance was a major item in the design of our house. It was a consideration that we had been very close to when we lived in California. We could see flames several times from our front step from passing fires. So we decided we're going to build a house here that is something we don't have to worry a lot about. On the outside of our structure, we do have some wood. I agonized over this, but we went with as large a wood as we possibly could, which is hard to set on fire, I have to say that. Our roof is metal, so if embers fall on it, they won't propagate a flame. We've cleared away, of course, as much as we can from the house here, and the house itself, with structural insulating panels, insulating concrete forms, and stucco exterior, is very difficult to set on fire. And once this is covered with stucco, an inch or so of stucco on here, 3/4 of an inch of stucco. They're really shortchanging you. When I was a little kid, they used to pile the stucco on. Today, with space-age materials, it is a little bit thinner. But with that on here, the device itself has about a 4-hour fire rating, I believe it is. Another thing we observed over in California is that the window frames themselves can be a problem. These are aluminum. I observed a fire just before we left in California where the folks had built a very nice insulating concrete form house and used PVC framed windows. I'm not speaking ill of PVC windows. In a lot of cases they're very nice. However, the only damage these people had to their house in a major fire that was actually consuming houses around them, the only damage they had was the PVC melted out of out of the structure and let the windows collapse, and they had some minor smoke damage. So I said, well, aluminum is the way to go, metal is the way to go, and that's what we did here. So we've got massive timbers on the outside, we've got a good layer of stucco, we've got a metal roof, we've got metal framed double glazed windows. Another fire that I observed close hand had several newer houses, but not new enough to have double glazed windows, and some quite a distance from the actual fire itself had caught on fire because the heat from the fire went through the single pane and set the curtains on fire. Blam. Double glazing prevents that. If you don't break the thing, you're going to be okay. But fire resistance is a major concern here.